For topic 3, we're going to look at a few different applications. Example 8 I originally had with topic 2, but topic 2 was getting kind of long, so I moved it here with topic 3. Okay, so example 8 says, without using a calculator, find the exact value of each expression. Okay, so for part A, we have sine squared of pi over 3 plus tangent squared of pi over 4. So we need to go back to that table where we filled in these values. So if we go back, sine of pi over 3, well, pi over 3 right here, we have sine is equal to root 3 over 2. And then we also wanted to look at tangent of pi over 4. Well, pi over 4, we have that tangent equals 1. Okay, so we're going to fill those values in. So remember, sine of pi over 3 is root 3 over 2. We want to square that. And then tangent of pi over 4 is just 1, and we want to square that. Okay, so when you take a fraction and square it, you're squaring each portion of the fraction. Okay, so root 3 squared and then 2 squared. And then 1 squared is just 1. So let's think about root 3 squared. Root 3 squared is root 3 times itself. When we do that, whenever you take a radical or a square root and multiply it by itself, you just get the radicand. And that should kind of make sense because root 3 times root 3 is root 9, which simplifies to just 3. Okay? So what we get here is 3 over 2 squared, which is 4. Now, this 1 that we had the tangent squared, or tangent of pi over 4 is 1, and then we squared it, which still gave us 1. Let's see if we can write that in fraction form with 4 as a denominator. So is there a fraction out there that has 4 as the denominator and has a value of 1? Well, absolutely, just 4 over 4. 4 divided by 4 is 1, and now we've got a situation where we have common denominators. And as long as we have common denominators, we can add numerators. So 3/4 plus 4/4 is 7/4. So when we evaluate sine squared pi over 3 plus tangent squared of pi over 4, we get 7/4. Okay, now let's do the same thing over here. We have sine of 60 degrees times cosine of 45 degrees. Well, let's remind ourselves, if we go back up here, pi over 3 is exactly the same thing as 60 degrees. And we already know that sine of pi over 3 is root 3 over 2. So sine of 60 is also root 3 over 2. So this becomes root 3 over 2. Now we want to multiply that by cosine of 45 degrees. Well, cosine of 45 degrees is root 2 over 2. So we get root 3 over 2 times root 2 over 2. Well, we can multiply things that have that are under a square root. As long as the index on the radical is the same and a square root and a square root share an index, you can squish all this under one radical. So we can say square root of 3 times square root of 2 is just square root of 6. And then our denominator here, 2 times 2, that just becomes 4. So we multiply across, root 3 times root 2 is root 6, and then 2 times 2 is 4. So when we evaluate sine of 60 times cosine 45, well, sine of 60 degrees, cosine 45 degrees, we get root 6 over 4. And then finally, we have cosine of pi over 3 minus cotangent of pi over 4. So let's go back to our table. So pi over 3 is 60 degrees. We want cosine of that, so we know we're going to get a half. So cosine of pi over 3 is 1/2. Okay. We want to subtract cotangent of pi over 4. So pi over 4 cotangent, we just get 1. So we want 1/4 minus 1. Well, or not 1/4, 1/2. So right here we have pi over 3. Cosine of pi over 3 is 1/2. I have no idea where my fourth came from. Okay, so we're going to say this is 1/2. Okay, so I've got 1/2 and I need to subtract 1, but is there a way that I could write 1 as a fraction where the denominator is 2? And the answer is absolutely. It would just be 2 over 2. We know 2 divided by 2 is really just 1, but now we've created a situation where we have common denominators. So I subtract 1 minus 2 in the numerator is -1, and then we just keep the common denominator. So when we evaluate cosine of pi over 3 minus cotangent of pi over 4, we get -1/2. All right. Now, calculators should only be used when directions tell you to round or approximate. Okay. Be very mindful of whether your calculator is in degrees mode or radians mode. Every math student on the planet has gotten points dinged because they forget to switch their calculator mode. Okay. So here we're just going to show you how to use your calculators. Make sure you understand how to input trig functions um, in degrees or radians. I have no idea who's just calling me. Okay. So example 9 says use a calculator to find the approximate value of each trigonometric function, round to 2 decimal places. Okay. So cosine of 15 degrees. Our calculator can do this for us, but we have to make sure that our calculator is in the right mode. Your calculator, as long as you have the TI 84 calculator, it can calculate these trig functions. But you got to make sure you're in the right mode. So is this it? Maybe this one. No. Whoops. I've got to find the right screen here. I think it's this one. There we go. So here's our calculator, okay? And in this calculator, if you look right beside the blue second button, there is a button that says mode. You've got different features on this calculator that are hidden. You use the second button to get there. So if we go to the mode button, oh, well, we don't really have to use second here. But if we go to the mode button, if you scroll down, you can see radian and then degree. The calculator is currently calculating any of the trig functions in radians. We do not want that because we want to find cosine of 15 degrees. So we want to scroll down until we get to radian and degree. We want to scoot over to degree, and then we want to hit enter. And you can see it unhighlights radians, and now degrees is highlighted. So we can hit second quit, and that takes us back to the main feature, the main screen of the calculator. Okay, so mode, you don't have to hit second, just hit mode. And then when you hit second mode, it'll take you back to the home screen. So now I want to hit cosine. So you can see we have these 3 trig buttons. So above the number buttons, we have a comma, and then we have parentheses. Above that, we have our 3 main trig functions. So cosine of 15 degrees, hit enter. And we wanted to round this to 2 decimal places. So we would round this to 0.97. Okay. So cosine of 15 degrees is approximately 0.97. Okay. So approximately 0.97. Now we want to find cosecant of 10. Now notice there's not a degree symbol here. So the first thing I notice is this is in radians. So we need to switch the mode on our calculator back to radians, okay? Also, I need to remember that cosecant of theta is equal to 1 over sine of theta. So when we go back to the calculator, you'll notice there's not a cosecant button, but there is a sine button. So what we would want to do is rewrite this as 1 over sine of 10 radians and input that into the calculator. And that'll tell us what cosecant of 10 radians is. So let's go back to the calculator. First things first, we need to switch our modes. Remember, just hit the mode button. And then we want to go down until we see radians, hit enter, and it'll take the highlight off of degrees and back onto radians. And now our calculator is calculating things in radians. Now to leave this screen, this is where you hit the second mode is the quit button. It'll take you back to your home screen. So we want to type 1 divided by sine of 10 radians and hit enter. And we want to round to 2 decimal places again. So we would say this is negative 1.84. Okay. So, whoops, negative approximately negative 1.84. Okay. So cosecant of 10 radians is equal to negative 1.84 approximately. Okay, now last up for these applications, we're going to look at a couple of just word problems, and then we'll go and do another topic where we talk about very specific types of angles. So in example 10, it says solve, include correct units with each answer, round to 2 decimal places as needed. Okay, so for part A, it says find the distance from A to C across the gorge in the illustration below. Okay, so we have this illustration, and you can see they have labeled A to C. We want to know what this length here is. Let's call it just X or something. So let's say this is X, okay? Now I have this angle right here, which we're told is 35 degrees. And then what I am trying to find is the side opposite that, And then what I've been given is the side adjacent to that. So let's think about this. When we're talking about these trigonometric functions, we have these ratios of sides that are really, really important. And we've been using SOHCAHTOA. So that tells me that sine relates the opposite side to the hypotenuse. Well, I need the opposite side, but I don't have the hypotenuse, so I can't really use sine here. Cosine relates the adjacent side to the hypotenuse. Well, I know the adjacent side, but I'm not interested in the hypotenuse, so that one's not going to help me. Now, tangent relates the opposite side to the angle compared to the adjacent side of the angle. Okay, so in this case, we need to consider tangent. We can use tangent to help us solve here. So remember that tangent relates the opposite side to the adjacent side. And that's going to help us out perfectly here because we have the adjacent side to the 35-degree angle and we need the opposite side. So we can create a little problem here that we could solve. Okay, so if we take tangent of 35 degrees, it would equal the opposite side over the adjacent side. And in this case, the opposite side is x. We don't know what it is, but we do know that the adjacent side is 100 feet. Okay, so I have tan of 35. Let me actually scoot this down so I have a little bit more room to solve this. Okay, so we have tan of 35 degrees equals the opposite side, which we're just going to label it x, over the adjacent side, which is 100 feet. Now, if I wanted to solve this equation for x, I need to get x alone. The issue is this divide by 100. Well, I can get rid of that fraction. I would just multiply both sides of this problem by 100. And when I do that, the 100s on the right cancel. Okay? So that leaves me with just x. And what we have is that x equals 100 times tangent of 35 degrees. If we can solve this right here and round to 2 decimal places, we can get the distance across this gorge, which is the length of A to C, which we said is just x. Okay, so let's go back to the calculator. Make sure you've written this down before I switch screens. Remember, I don't love my calculator setup, but we use what we have. All right, now, last I used this calculator, I vividly remember converting it to radians, but you need to get in the habit of checking because if you have your calculator in radians, but you're using 35 degrees, you're going to get a wildly wrong answer, okay? So let's just double check our mode. So our mode for sure is in radians. We need it to be in degrees because the angle that we were given was 35 degrees. So we go over to degrees, hit enter. It's now highlighted. So we hit second quit. And the equation that we needed to type in was 100 times tangent of 35 degrees. And we hit enter and let's round to 2 decimal places. So we get 70.02. So let's go back to the worksheet. So this equals 70.02 feet is the correct unit. And what that is it tells me this distance here from point A to point C across this gorge. So the distance across the gorge is a little over 70 feet. Okay? Now let's look at part B. So part B, we have a 22-foot extension ladder is leaning against a building, okay? And it makes a 70-degree angle with the ground. So let's draw our building. So we're going to say this is our building. All right, it's beautiful, okay? Like I've told you before on many things, an artist is not one of them. We've got our angle leaning up against the building. We know it's 22 feet long. We also know that it creates a 70-degree angle with the ground. Now, our goal is to figure out how far up the building does the ladder touch. So our goal is to find this distance right here. So let's call it X, okay? So our goal is to figure out how far up this building is this ladder leaning, okay? So we need to see what we've got here. We don't have the adjacent side to this angle. So with where 70 degrees is, the adjacent side is unknown. So is the opposite side, but we do have the hypotenuse. So we need to find the opposite side, and we already have the hypotenuse. So it looks like sine is going to be really, really helpful here because sine relates the opposite side to the hypotenuse, okay? So sine relates the opposite side to the hypotenuse. So if I were to take sine of 70 degrees, I could create an equation here. So sine of 70 degrees equals the opposite side, which we're saying is x, over the hypotenuse, which we're saying is 22 feet. Now, I need to solve this equation for x, and in order to do that, my issue is this division of 22. So we can undo division with multiplication. So I want to multiply both sides of this equation by 22. Well, when I do that on the right, 22 divided by 22 is really just 1. 1 times x is just x. So I get that x is equal to 22 times sine of 70 degrees. So make sure you've written this down before I switch screens. So we need to go to the calculator. And I definitely converted my calculator to degrees, but you need to get in the habit of checking. So let's just check. Our calculator is definitely in degrees mode, so we're good. So I can hit second, quit. Now remember, we had 22 times sine of 70 degrees. Hit enter, and let's round to 2 decimal places again. So we get 20.67. Okay? So 20.67 what? Well, x equals 20.67 feet up the wall. So remember, the question that we were asked is how far up the wall does the ladder touch? Well, the ladder touches 20.67 feet up the wall, assuming we have a 22-foot ladder and it makes a 70-degree angle with the ground. Okay, so that's it for these examples. In the next video, we're going to talk about angles of elevation and angles of depression. Similar-ish ideas to this, we just have to draw slightly different pictures. Okay?